We're going to explore more about slope. In lesson 212, use the horizontal and vertical distances of a slope triangle to measure the steepness of a line. Today, you will use the idea of stairs to understand slope even better. You will review the difference between positive and negative slopes, and will draw lines when given information about change in x and change in y, or delta x, delta y. Excuse me. During the lesson, ask your teammates the following questions. How can we tell if the slope is positive or negative? We talked about that a bit in the last episode. What makes a line steeper? What makes a line less steep? What does a line with a slope of 0 look like? So one way to think about slope triangles is as a stair steps on a line. Good God, reading is hard. One way to think about slope triangles is as stair steps on a line. Ugh. Picture yourself climbing or descending the stairs from left to right. We talked about that in the last video. That's a big one. In America, we read left to right. Go left to right. It's always going to be easier to tell if it's positive or negative if you go left to right. On each of the lines below, of lines A, B, and C, which is the steepest, which is the least steep? Well, it looks to me like B is the steepest, and it looks like I guess this is cut off here. Let me get the letters here. I'm sorry. All right, I apologize. So I have C and D. So it says of lines A, B, and C, which is the steepest, which is the least steep? Well, B looks the steepest, and C looks the least steep, I would say. Examine line D. Well, B was the steepest and C was the least steep. Examine line D. What direction is slanting from left to right? Well, this is going down. What number should you use for change in Y? I would say you should use a -2, not a +2. Again, we talked about that in 212 video if you want more in-depth explanation. So find this graph on the resource page and label the sides of a slope triangle in each line. I'm probably not going to do that. I'm probably just going to do it right here. So here I have -2 and 1, 2, 3, 4, 5. So D is -2/5. As a matter of fact, I'll write that. Remember, that's my M, or my slope. C, I have a rise of 1 and a run of 2. Again, I prefer a rise of 1 and a run of 2. I like it better like that, but whatever. So M is 1/2. Here, we're going to say a rise of... Is this thing all scaled? Oh, that's just a 5. I thought it was saying it was going up 5. I was so confused. All right, so it goes up 1, 2, 3, and over 1. So this has a slope of 3/1, and this one is 1 and 1. So this one has a slope of, I guess I'll just, has a slope of 1/1. So label the sides of the slope triangle, then determine the slope of each line. So I've done that. How does the slope relate to the steepness of the graph? So this is kind of important here. You can see that 3, this simplifies to 3, right? That's the biggest number here, and it's the steepest one. 1/2 is the lowest number here, and it's the flattest, right? Because this is 1, so it's like 3 versus 1 versus 1/2. Well, 3 is the steepest, 1's in the middle, and 1/2 is the flattest. And obviously, a negative means it goes down. So Cora answered part D with the statement, the steeper the line, the greater the slope. Do you agree? Yeah, I would say kind of the absolute value, right? Because if it was like a super steep negative line, it would have a negative, maybe like -8 or something like that. So yeah, I would agree. But like I said, I would also kind of add the caveat too, that it's like the absolute value of it, because if you just look at the absolute number, like, right, like if I have a slope like 1/2 and -8, for example, they would look like that. Let me pause, I'm sorry. Okay, so if I had this maybe has a slope of 1/2 and this maybe has a slope of -8. So if I just said, the steeper the line, the greater the slope, well, that is a greater slope, but it's not a steeper line. But the absolute value here is 8, and then there you go. That would be the steeper line. So I hope I made myself clear. I don't think I did. So find the graph shown on the resource page. Again, I'm just going to use this here. Which is the steepest line? It's kind of hard to tell. It looks like A is the steepest line. So I will say A is the steepest line. Which is steeper, B or C? Well, B goes up 1, 2, 3, and over 2. So that's 3 over 2. And C goes up 1, 2, and over 3. So it definitely looks like B is the steeper line. Draw the slope triangles for A, B, C, and D. So A is going to be, well, I guess why would I put it there? And cross the next line. So A is going to be 2 over 1. We already said B was going to be 3 over 2. So we'll go ahead and draw that. I guess I have to cross a line I don't want to. We already said that C was going to be 2 over 3. D is down 1 and over 1, 2, 3, 4, 5. And E is an interesting one because E doesn't go up. And it goes over as many as you want. So just pick a point. I don't see that it has a point. I'm not sure. Maybe I kind of wrote over it. Yeah, okay. So you can see the 2 points on E. It goes up 0 and it goes over 1, 2, 3, 4, 5. So that's just going to be 0. But obviously, I mean, on E, it wouldn't matter if you just went from here to here and say it went up 0 and over 1. You still get 0, so it doesn't really matter. So draw the slope triangles for A, B, C, and D. Label change in X over change in Y for each. It says match each line with the slope using the list below. There are more slope than lines. Okay, well, we already did this, so we know that this one right here is A. B was 3/2, so we know that's B. C was 2/3, so we know that's C. D was -1/5, so we're good there. And then E we said was 0. So these ones don't have partners. It says views left to right. In what direction would a line with a slope of -3/5 look like? Well, it would go down, right? We already said that it would go down 3 and over 5 because when we go left to right, a negative slope means it goes down. Viewed left to right, in what direction would the slope of -5/3 go? Again, it would go down. It would just go down 5 and over 3 as opposed to down 3 and over 5. And again, if it's negative, it goes down. How would it be different than the line in part D? This one would be a little bit steeper, right? Because -5/3 versus -3/5. This one has a higher absolute value, so it would be a steeper line. All right, let's go ahead and continue along here to 213 part B. All right, we already answered question 224. So if we look at 225, sorry, I got a little distracted here. Okay, so examine A, B, C, and D on the right. For each line, decide if the slope is positive, negative, or 0. So A appears to be a negative slope. B appears to be a negative slope. C appears to be a positive slope. And D appears to be a 0 slope, I would say. All right, so let's look at the resource page and graph a line to match each description below. So here's what I'm going to do real quickly. I don't know if I'm going to use the resource page. Let me just pause it and figure out what I'm going to do for 226. I'm not going to be able to use, I am going to use the resource page, but I'm not going to be able to look at what this says here. So I'm going to jot down these notes, and then I'm going to open up the resource page so that I can graph them, but I need to jot these things down so I don't have to bounce back and forth. Here's what it asked me to do. For A, it asked me to just draw a line that goes up 3 times every time it goes over 5. So let's say I was here. It would go up 3 times every time it goes over 5, and I would get a line that looks something like that. I missed. That's disappointing. I missed again. I give up. Okay, on B, it said, What if you have the x changed 4 and the y changed -6? So actually I'll start from here. Start from that point instead. And again, it's saying that the x changed 4 and the y changed -6. So it would look something like that. C said that the change in x is change in y is the same. So what if every time the x changed 1, the y changed 1? So it would look something like that. And then D says that the y changes 3 and the x changes 0. And we get a line that is straight up and down, which is interesting because we haven't really discussed this yet, and I suspect that we might end up discussing it in a minute anyways. But a couple of points I want to make here. First of all, this one is not a function. All these lines are functions. This one isn't because it has multiple outputs from one input. The other thing is, if you look at the slope, again, the change in y over the change in x, the change in y was 3 and the change in x is 0. And we've already talked about you're not allowed to divide by 0, and that's what you're doing here. So it's known as undefined. How steep is that? It's undefined, right? I don't know how steep it is because I can't divide by 0. We'll jump back over to the rest of 213, and I'm sure that probably will come up in the conversation, but if not, I at least wanted to kind of get that out there. So which of the lines graphed represents a function? We said that the first 3 did and that D didn't. If the line doesn't represent a function, y, because it had multiple outputs for one input. Okay, 228, draw a line with a change of y of 0. So that means it doesn't go up or down, right? It just goes side to side. So how can you describe this line? I would say it has a slope of 0. Now draw a line that has a change of x of 0. So the x isn't moving. And again, we say our slope is undefined here. Big difference between the two. So be real careful when you get to these kinds of slopes.